All right. Good afternoon, everyone. Welcome to my channel. Today I'll be teaching you some topics in physics, but today I'll be taking linear momentum. So the first you want to understand is on the concept of linear momentum. You want to understand what does it mean to be, what is linear? Linear actually, in a simple word, it means straight. Linear means straight. Now, what then is momentum? Momentum, we can simply say momentum is the product of mass and velocity. That is, momentum is the product of mass and velocity. Product of mass and velocity. And that means that we can say this is the product of the mass of the body and its velocity. So in that simple way to put it, momentum is the product of the mass of the body. Let me add body here, of the body and its velocity. So in other words, we can simply say momentum, all right, momentum equals to mass, which is in kilograms. The unit of mass is kilogram, multiplied by velocity. All right. Now, so if you understand that, then you will know that the unit of velocity is meter per seconds. All right. Now, from that understanding, I can move on to introduce to you in the case of momentum, which is when we say momentum, we can have it as mass, let's say m, and then we have times velocity. Now, which means it can simply give us mv. All right. Now we can move on to have what you call change of momentum. Now, if you say change of momentum, now before change of momentum, you have what you call initial velocity. Now, but since mass and velocity are coming together, we can say okay, initial momentum, let's call it initial momentum, which is equals to mu. Then we say final momentum. Stay with me, mv. So you have v and u, that is initial velocity and final velocity. Now from there we can now have change in velocity. Now when you say change in velocity, or change in momentum rather, my mistake, change in momentum, what does it mean? Actually, it's just like you go to buy ice cream of 20 naira and then you go with 15 naira, and on getting there you give them 15 naira, and then they subtract the value of what you are buying, which is 20 naira. Now your change therefore will be 30 naira. It's as simple as that. So let's signify that this 15 naira is the final velocity, which is the end of the transaction, and then let's say this 20 naira is the initial velocity, which is what actually kickstarts the transaction. So from that understanding, I can simply say that change in momentum is mv minus mu. If you are there, I know you are there. Now change in momentum. So from that place, I can then factorize, since we have m to be common to both sides, and say m into bracket v minus u. M into bracket v minus u. By the time you open this bracket, you will still get it as this m times v gives you mv, m times u gives you mu. All right. If you understand that, then I will bring you to the next step in this formula, and that is rate of change of momentum. Rate of change of momentum. Now, if we say rate of change of momentum, where did we get this concept? Now, from the Newton's second law of motion, second law of Newton's law of second law of Newton's law of motion. All right, we state that the rate of change or momentum of a body is directly proportional to the applied force, and it takes place in the direction of that force. So from that understanding, we have the rate of change of momentum. Now, the moment you hear the word rate of, now the first thing that should come to your mind is time, a kind of time. So we can simply say m into bracket v minus u over t. That is the rate there. So we can have the formula in this understanding. Now you remember very vividly that this v minus u over t is actually the formula for acceleration. from first law of motion that state that an object will continue to be in the state of rest until an external force or agent act on it. All right, now thereby changing the position of the body from where it was to another position. Now you remember vividly that the law of that first law simply means V equals to u plus AT. Yes, V equals to U plus AT. Now it is from here we're able to deduce this particular formula, and then you know this A is acceleration, all right, and this is the formula for acceleration. So we can say, okay, since we have that, and then we can answer, okay, F equals to KMA. Now where K is the constant, all right, so where K is constant, now since K is a constant and the value of it is 1, the value of K is 1, so therefore we can say therefore F equals to MA, and then you understand very carefully that F can therefore becomes F equals to M into bracket V minus U over T, all right, over T. Now, so which means you have the formula for acceleration here, and then you have the mass beside it, and that brings us to the end of the formula for moment. In the next section, we are going to take an example on that. Thank you.